Hello there, friends. Welcome to the episode number 17 of Take It EV 17. In today's episode, we're featuring an interview with Chris Hazel from ZeroEVs. Look it up on the YouTube, but listen to the interview first, obviously. We're talking with Chris about converting your classic or otherwise regular cars to EVs. Enjoy. Chris from ZeroEV, welcome to Take It EV.
Yes, I'm Chris from ZeroEV. Me and my business partner Alex started ZeroEV just over 2 years ago now. It was sort of both of us had experience in EVs before that, but we were all sort of doing DIY based stuff, basically. And then a project came up, which we bid on and we won, which was to build 3 stunt cars for a show in Macau, one of the casinos. Wow. So we built 2 350Zs and a Porsche 911, fully electric, to do drift demos and stuff in the stunt show in Macau called Lecron. That ran for about a year. So that was what started us off. And when we won that contract, we went all into it then, basically. And I shut down my other business, which was doing custom vehicles, and went straight all into EV. Since then, obviously, it's just grown and grown and grown. We've sort of, I suppose, we just look for the gaps in the market and produce the products which no one else seems to be producing or is massively overpriced. Even simple things like buzz bars for Tesla, the batteries and things like that, where you build singles and they're stupidly expensive, but we build them in the hundreds and it makes the price a lot better, basically. So we've been focusing on those bits and trying to make the systems as plug and play as possible. So trying to fill the gaps in the systems rather than having lots of different parts. Try and have it so each part talks to each other properly.
Yeah.
And just trying to make it easier for people, I suppose. I mean, all the stuff we're now doing on YouTube, obviously we're trying to follow our builds step by step. So people can actually see the full process and all the parts that go into a build. Because there seems to be, what we found, a lot of the other EV companies would show the end of a build and the beginning of the build, but they wouldn't give away any of the magic in between. They just give away a little bit and no one would really know the full in-depth side of things. So we're trying to push that now and trying to explain to people the in-depth side of things, because we're not particularly worried about other people starting to take this on and do it, because there's not enough people out there at the moment doing EV conversions in the world anyway. And for us, the company for us is more based around short production runs of kits. So we're about to start producing Porsche 911 kits, for instance, that comes as a pre-built complete kit that you bolt into your Porsche. So you haven't got to source everything, build everything from scratch, all pre-built, all the battery boxes are made, sealed, ready to go. And the supply of components, that's sort of our area. We're going to do the kit, the components, not as much the conversion side of things, more support other people that want to do it, other conversion shops that want to open up, sort of try and be their supplier and support so we can train them throughout the process so they learn how to do it. That's sort of the gap where we're coming in, I suppose, is to be that enabler, shall we say, to enable people to start doing EV conversions, which should in turn hopefully bring the prices down in the market for the conversions, I hope, because at the moment it is very, very specialist. But hopefully if we make it a little bit simpler, it should be easier for more just general engineers and mechanics to get involved with it, rather than being so scared of it and it being such a massive daunting task.
Okay, so let's sort of rewind a little bit. So why would one want to have the ICE car converted into an EV? What is your typical sort of person that does it? I'd
probably say the typical person that does it is a classic that has some high value already. And the way in which we basically push the conversions is so it's reversible. The classic maintains its high value long term. The prices on the EV conversions probably aren't quite there yet to do the mainstream vehicles, because the price of conversion is still quite high. It's the amount of time and labour that goes into developing it and designing it to go into that vehicle. I think it's high value classic. Our customers are people that have probably got a bit of disposable income, to be perfectly honest, that want a Sunday driver or a vehicle to drive to and from the office that is actually green and isn't going to be polluting. So some of it it's probably to show off a little bit.
Yeah. So you have a good looking car that's classic or old, but you want it to be an EV, basically. And is that the reason why there's, so many of the EV conversions that I see around, they're always kind of underline the fact that they're reversible, so you can always go back? Is it?
Yeah, I
that's the reason.
think most people will never turn them back, but for some reason there seems to be a hurdle.
It's just having that ability.
Yeah, it's just a hurdle that people seem to think they need to have the option to go back. They should have to be able to. Actually, they never will go back. But it's just that it seems to be a selling point. Otherwise, people won't do it. If that makes sense. Even though they will never convert them back. It's just...
It's an insurance policy, basically, right?
Yeah, it is. It's definitely. But there is companies coming out now that we're working with that are actually going to be producing purpose-built EVs. So they're producing Porsches and Pagodas and Jaguar E-types that were electric. They're building them as electric.
Okay.
But they're selling them as a built electric classic. So they're not designed, but we are designing them with them to be reversible, but they're not being sold as a reversible. They're being sold as, here is a fully built electric classic car, basically. And that's sort of, I think there's a couple of companies come out that we're working with now that are going to start doing that sort of thing, offering that sort of service. It should be good.
Okay. So what qualifications of sort of what skills do you need to have to be able to convert a car to an EV? So say I have a 911 sitting on my drive, and I just have a house with a drive and a garage maybe. Can I do it myself, or do I need to have what do you think, apart from like the being able to...
It's quite a grey area. I think mounting the motor, doing some of the wiring, fine. The concern that we keep coming to and keep going back to is the battery packs, building the battery pack safely and designing it correctly to go in the vehicle. People can do it themselves, but it's whether they do it safely. Because in the UK, there isn't really any strict legislation on this. In Europe, they're a bit stricter. But in the UK, in theory, you can get away with doing most things. But the big concern we have is that of a DIYer hurting themselves. Because if a DIY hurts themselves, it will affect the whole market, not just that one person. It will affect the whole industry. As soon as someone does something stupid, then that will have knock-on effects to everybody in the UK. So that's where we play a bit of caution. And we're trying to develop the kit. So like the MX-5 we're doing at the moment, that's being done in a way that if we supply that as a kit, it will come with all the parts, but the battery pack will be built in our battery build room on our jigs as a sealed battery pack. So the only thing you've got coming out of that is the high voltage connector and the data connector.
Yeah.
No one's got to do anything inside of it. So it's a sealed package. So I think that's the approach we're taking, is we're trying to do it. So actually we'll supply the built pack, and then someone can do all the other conversion stuff themselves.
Okay.
People can build the battery packs, don't get me wrong, and people have been.
Yeah.
It's just, I always see photos of potentially dangerous builds of battery packs. And I don't know whether we're getting a bit blasé with the risk, and just getting used to it, I suppose. I mean, obviously I work with it every day, so I do things naturally because I've been working with it for so long. It's hard for me to look from a point of view of someone that's never done it before now.
Yeah.
But yeah, the big risk is the battery pack. That's the single biggest risk of everything. And people taking a salvage battery pack and taking it apart without knowing how they're taking it apart, and maybe not removing the fuses first, maybe not splitting the pack down into sections. They're working on a completely live pack, and all it takes is to put one spanner down somewhere or touch something. Or people working with two hands at once on a battery pack. Like, there's certain things that, as a novice, if you're going to do stuff, put one hand behind your back, so you can't touch the positive and negative. You've only got one hand. The risk of you touching both positive and negative at once is greatly reduced.
Yeah, that's actually a good point.
It's very little things. Just little things that it's force of habit. Remove all metalwork. Put one behind your back. Use insulated tools. It's all those little stupid things that I suppose everyone would take for granted, but actually they'll save your life if you do something stupid. So I mean, there's a place for it. It's just trying to illustrate to people about safety, and trying to make sure everyone does it safely. We don't want to tell people not to. At the end of the day, we supply parts to people, so we're there to supply the bits. It's there's always a big risk there.
You're not going to be able to control people. Like, if they wanted to do something, they'll find a way, right? So if they have,
if we turn around and say no, don't do it, they'll do it anyway.
Yeah, so if you can provide them with something that's safe and actually, makes sense, they'll hopefully buy it from somebody who knows what they're doing. So do the battery packs that actually you guys supply, do they have the contactors inside so they're safe until you give them the right information to open up, basically?
Yeah.
Okay.
Yeah, exactly. So all our packs we do, they have dual contactors inside and the pre-charge built inside. The battery management system is internal, and then we tend to do them. We don't do them with tails coming out anymore. We have them with a proper high voltage connector now. And if that connector is not in, there's basically a cut loop within the connector pins. So if that's not joined together with the connector and it doesn't allow the contactors to even engage, you've got to physically have that connected in to allow that. So we've gone to as far as we can safety. They're sealed. You have to have tools to get into the pack. It's not just undo a clip by hand. You've got to have tools to get into it. It sort of we aim to meet the European regulations, which is the R100.1, which is basically just set regulations in Europe that you should always aim to meet when you're building a battery pack, just for safety.
Okay, so you do like leakage control and all that as well?
Yeah, we bought fancy new tester recently, actually, to do leakage control.
I know it's a funny, I won't go there. I don't want to geek out too much, but when I was at sort of late teens, I had a job experience at a place that fixes trams. And I had to wear funny boots and funny gloves to actually work on live because it's a DC 300 volts or whatever. So, when you're screwing a bolt or whatever, you have to actually wear safety equipment just to do it on live equipment. And it's scary to touch something that's DC, like such a high voltage.
Yes, definitely. The other thing is the battery management system we run we run the Orion battery management system, which is probably a bit more of a higher end system. There is more budget ones out there that people use, but there's other benefits to having that because it does have a leakage sensor. So it senses leakage, and then if it sees there's leakage, it will shut down. So it will shut your system down if it senses it. There's little key things in certain items we choose for a reason because it has additional safety that people would tend to probably overlook on the more lower end battery management systems and stuff. From our point of view, probably the most important item on there.
And obviously that battery pack is also sealed, right? So it's weather sealed.
Yeah, it's weather sealed, and then
which is another important thing.
Yeah, you want to be weather sealed. I mean, normally, ideally metal. They don't have to be metal, but it seems to be becoming a bit of a standard in the industry. Some people have used sort of fiberglasses, carbon fiber sort of stuff. But the reason we tend to do metal is, one, it gives a bit of impact protection. Two, it gives, unfortunately, some fire protection. As much as it shouldn't happen, but battery packs do occasionally go wrong. So it's not going to stop it from going wrong, but it's that thing of, say someone, God forbid, had an accident and caused an issue, ruptured something, it gives that person time to vacate the vehicle. It's not going to stop it once they go up. But this is why Tesla and all those companies have huge these metal battery packs, because if someone does have an accident and it did, for instance, set on fire, it gives you that time to get away from the vehicle, get out of that vehicle. And we tend to fit valves to our battery pack, so equalization valves. So it allows the battery pack to equalize. And also those valves are normally in a position that, say something did happen to the pack, that would be the most likely venting point. But those valves are normally faced downwards towards the floor, a bit like Tesla do along the sides of their battery pack. So there's certain things you do like that just to try and, if something did happen, you've done it as safely as possible. You've ticked as many boxes as you possibly can, I suppose. It's one of those things that it's very hard to do for like even a person who knows what they're doing. Most people not going to have all that kit and knowledge at their disposal, and they're not going to be able to test it and make sure that actually it works and performs very well before they put it in a vehicle. Because when you do it yourself, there's only so much time you have on your hands, right? So, and which is why we're trying to cover everything and make everything available for people to just buy off the shelf. Then they haven't got to look around for these parts. They haven't got to think too much. They can sort of go, well, that's what they stock for a reason. So if we just use those bits, that automatically brings in loads of their additional safety without them even thinking about it.
Yeah, and also when you presumably when you build an EV, the details that you want to care about as a DIYer, you are not in a battery pack. You want that bit to just be you slot it in and it works. You don't want that to be the bit that you're going to fiddle with, basically. But just for the because I know what it is, and you know it probably well. I'm sure you know what it is probably better than I do. But just for the benefit of my listeners, the leakage control is basically it's a question that I get from time to time. It's what happens if one of the terminals of the battery pack is exposed to the chassis of the car. So basically, that's why you're it's not going to kill you because you're not closing the circuit, but you want the battery pack to shut down just in case another wire gets rubbed against the chassis of body of the car or something. So is that correct, or is there anything else that I'm missing?
So that's fully correct. So that's why you normally run a battery management system, because it will continually monitor the leakage to chassis. There is a tolerance, like everything. A lot of EV components, there will be some leakage, inevitably, but you're talking tiny amounts of leakage that you would never even know it was there. But the battery management system obviously continually monitors that. But that's just because of onboard electronics. And you think a lot of the EV stuff does go to have a grounding on it, just in case. You also, the leakage, if you do get leakage, it can cause damage to the other electrical components.
Yeah.
This is the other problem, because they actually have a ground there for a reason. So if you then got either your negative or your positive live to chassis, it's not that great. But you will find that a lot of systems that are below 60 volts will be negative ground.
Yes, yeah.
So a lot of the older stuff, a lot of the golf carts, I think, mainly are negative ground. The Renault Twizy, I think, actually is a negative ground as well, because it's not classed as high voltage below that voltage point.
Yeah.
A bit like on a car, I suppose, at the end of the day, 12 volt, your negative on your 12 volt in your car is to ground. So there is a point in which that's still allowed. I think it's up to around 60 volts, but don't quote me on that. I'm sure it's 60-ish volts.
I'm sure there's a standard for it somewhere.
Yeah, there's a standard for it. I think it's around 60 volts. And then as soon as you go over that, it's then classed as high voltage. So then you can have that basically in place. But as you said, you need to be able to touch the other side of that battery to complete the circuit.
Yeah, I was told that because, I understand that people are afraid of these things. So things being watertight, I get loads of questions about whether I can drive my EV in the rain or put a puddle. And I've been driving through a meter of water in my Nissan Leaf many times, and I had people following me in Subarus and whatever, and they got stuck, and I just carried on because we don't need the oxygen to run the engine, right? It's if it's all done properly, it's all concealed and it should be watertight. We're going to go back to the EV conversions themselves, but how did you yourself come across EVs, or are you driving an EV at the moment, or what is your connection to the sort of to the EV world?
So I was doing custom vehicles, was where I started doing. So I used to do things like wide body Audi R8 and all that sort of stuff. And then I got a call one day to basically say that someone I knew had a Tesla large drive unit had come in.
Okay.
And I didn't know what to do with it. So I bought that just randomly off the cuff. It's like, I'll have a play with this. And then after I started hunting, how do I get this thing to work? Hunting around. And I then came across Kevin Sharp and Damien Maguire, which a lot of people probably heard of Damien, who does a lot of open source stuff. So we came across each other, and Kevin's split screen bus came to me to have all the custom work done. So I built the battery packs and everything. That was my first one I started doing myself. And at that point, that's when I met my business partner, Alex, and we did that bid. So that was how I got into it. And then we worked very closely with the open source community for probably a year and a half, I suppose. We did a lot of funding, funded them an awful lot to do a lot of their development, to help them to grow with the Tesla control boards and all that sort of stuff. Always within the agreement that we'd fund them to grow, and we'd also always end up with our commercial version as such that we use, which we developed a bit further afterwards.
Okay.
So we did our support back into open source, and that's where we got into it. Really, we started open source. That was where we started, and we still do bits open source. We have actually just been doing the Mitsubishi Outlander motors from the PEVs. So we've just got them spinning, and all of that's open source, or will be open source for the DIYers, because you can pick those parts up extremely cheap. So they should open up the market massively for people when they come out very soon. But we'll be doing that on our YouTube channel and showing that, here's where you get the open source information from. Here's where you buy all the parts from. Here's the cheap parts to buy. just because we're not going to damage our customer base by helping some of the DIYers out, because they wouldn't come to us in the first place, just because obviously we are a little bit more high end on component costs and stuff, I suppose.
Okay. But yeah, it's amazing how many hybrids and PHEVs, which are hybrids essentially, they've got pretty powerful motors, because they're usually very heavy cars. So if you're converting something light like a Porsche, or that's fairly light without the engine, you can just put a motor like that just to have a runaround. I'm sure I'm wrong somewhere on that, but I've seen
you're doing. I mean, like the PHEV Mitsubishis, I think both the motors are 70 or 80 kilowatts each, so they're more than ample. Any vehicle you've got that's under, say, 1,200 kilos, it's going to shift with just one of those motors. It's pretty good, especially if you put it through the right gearing as well. So that should be quite. We're actually putting the 70 kilowatt motor out the back of the PHEV in a Renault Twizy.
Wow.
So that's our next build on YouTube. It's going to be a 100 brake horsepower Renault Twizy.
There's a guy that I know who would love that. I don't know if you know of the Kate and James on YouTube.
Yeah, no, I know Kate and James. Yeah, we know Kate and James.
Okay.
They came down. James came down and did some test driving in my Skyline.
Okay, yeah.
Yeah.
He's got a connection and history with Twizzies, so I'm sure he would love to have a go.
Speak to him, quite a lot. That was the other thing, I suppose. Yeah, you said where I got into it. I built my electric Skyline with the Tesla motor I bought. That's what I built. So I built an R32 Skyline, which is still doing the rounds. It's got a couple of sponsors, and it's sort of out and about, and it does drift demos, and different drivers use it at different events. Been at Goodwood Festival Speed last year and did some stuff there. But that was the car I built myself. That's my personal sort of car, but it's not road legal anymore. It's now just full sort of race drift spec. There's nothing road legal about it. And then we've just built the electric Porsche Boxster, which is going to be my daily driver, just to get some miles on it, sort of a test bed, but just test a new software on a new product. I have about a 50-mile a day commute, so it's sort of both ways. It just puts the miles on the systems, so we can test stuff out.
Okay, and once you've converted a car and you're driving a car like that on a daily basis, how does that compare to driving, just a regular car that you buy, of like an EV? Like if I bought a new Nissan Leaf, what is the comparison in like day-to-day driving?
To be honest, it's sort of the same. So we can do one pedal braking like you can in Nissan Leaf. We can adjust the regen amount, adjust all that sort of stuff. So it's silent. It drives just as smooth as a normal EV does. I think the benefit I find with things like the Porsche and stuff is they were built to handle and to be high performance.
Yeah.
So the benefit with those, if you go and chuck the electric system in, you maintain that performance or increase it, you've got a really good, very well designed base handling vehicle. Whereas I will say a lot of the EVs that are on the market now were not designed for that. So even the Tesla Model 3, they handle all pretty good, but they weren't designed like Porsches were designed. They weren't designed to sort of, handle stupidly good in corners. Or they are, but it's all done through onboard electronics.
Yeah,
it's not mechanical.
I'm sure I'll get a load of mail.
Yeah. It's not physical, mechanical sort of, it's everything's electronic. So when you take the classics that were designed for that, like the Porsches, it's phenomenal. So like the Boxster handles like the Porsche, but then it's also got the electric side of it. So it's weird, especially on country roads, because you can still hear the wildlife and everything. You haven't got this flat box, this flat V6, flat 6 or whatever it was in the back of it, dumping away. So it's like a normal EV, but I think I prefer it over buying a new EV, just because you've still got that. I think with the classics, most people have got some sort of childhood tie to them, like that I love my first car sort of feel, but they wouldn't have their first car again because it's unreliable. And whereas actually people can have their first car again, or the cars they had one like 20, 30 years ago, and actually have one and have it reliable. So I think that's quite a big focus for a lot of people, is to be able to do that and have that old classic that brings back all those memories. I do get mail every now and again from someone going, well, it's expensive to convert, I may as well just go and buy a new car. And it's like, well, if that's what you want to do, fine. But a lot of people miss the point. It's not about having a a new car. It's about actually having an old car with memories and quirks and having fun, not just having an A to B car, basically.
But at the end of the day, EV will be more reliable, right? It's not going to be... You're not going to get all I suppose some people like the sort of tweaking the engine and, opening the bonnet and, I don't know, changing the oil and all that. I've got a neighbor here who's got some sort of an old... I don't know what it is, actually. Like an old classic car that he just pulls out every Sunday. Literally just drives it down the road to the shops and back, and puts it back in, and that's it. That's all he does in that car. Do you get lots of people being surprised by your Porsche being quiet, or do you get other Porsche owners kind of inquiring about it? Yeah,
it's a bit of a mixed messages, I suppose. Like you said about your neighbour, like the reason he only drives it on a Sunday is probably because it's probably not reliable enough for him to drive every day. That's normally what it is.
And he's retired as well.
Okay. But that's what we tend to find is a lot of people have got these nice classics and they won't drive them because they don't want to put miles on the engine because the engine costs a fortune to rebuild and all that sort of stuff. So it's difficult. I suppose it's still very much a very mixed community, but a lot more people are coming round to it now. Like for instance, the new build, so that MX-5 build will do, and that was a very much didn't know how people were going to take that, because that could have gone one way or the other quite quickly with the MX-5. But everyone actually is on board, and even the people that don't like it secretly like it because of the amount of engineering and the development and stuff that's going into it. So they've sort of got a love-hate relationship, I suppose, because a lot of these people that do the tinkering on the cars, as much as they don't necessarily like the idea of EV, when they see the amount of work that goes into it and the design side of it, they can't not be interested in it because they like being hands-on, they like tinkering and stuff. Like yourself being an engineer, that's the sort of thing that you thrive on. Even if you're still a little bit on the bench about it, when you see that side of it, I think it gets a lot of those people excited. They just don't want to let it on. They don't want to let anyone see that they are.
Yeah, well, MX-5 is one of those cars that's kind of, people love them. And if you had one in the past, I never drove one, so I don't know personally. But if you love the way it is, it's one of those cars that kind of get you in, and I don't know. I know loads of people who have a nostalgia about that car, or who had one in the past, and they, 10 years on or 5 years on, they bought themselves a used one just because they liked it, and it's just a Sunday.
They handle brilliantly. I've had two when I was younger, and they just I don't know, something about it. It's just the handling of it, the fun of it, how it drives. Yeah, it's very much. They're a brilliant little lightweight car, which we're trying to keep it lightweight. Trying to.
Well,
we're getting there. It's not too bad. It's not too bad. But that's as you said, it's another one of those cars that people have got a real passion for.
Yeah.
And it is definitely, I think they will be one of the vehicles in the future that will get heavily converted once the parts price comes down considerably.
Unless they will rust quite a few cars down.
Well, yeah, the amount of rust that we found. Yeah.
Yeah, I have to say you guys are very brave for doing this kind of openly. Whether it's going to go. I'm sure you want this to succeed, but if anything goes wrong in the process, you're going to have to be like, well, the thing that I said in the episode 4, I'm actually going to have to revert or whatever. It's very brave to do this openly, because like you said, loads of people do convert things and then just kind of show you the preparation and then the final stage, and anything that goes in between is just left over. I do like watching and talking to people who are happy to share their experiences, because that's where the interesting stuff happens, basically.
It's where and it's also we looked at it from the safety side of it, because no one shares that information. Everyone out there doing it DIY is winging it a little bit. They'll read a bit online, they'll see bits, or they'll see a video online of another DIYer doing it. Now the problem is, not saying that DIY did it wrong, but the chances are if another DIY is doing it and another DIY is copying that person, they haven't done it necessarily to the set regulations.
Yeah.
So it sort of gets watered down. So we're thinking, well, if we actually cover it from a commercial side, then people might pick up on those bits and try and... We're going to make all those bits available. That's the other thing, is we'll make all the proper buzz bars available, the proper connectors, the proper cooling plates. So try and make everything available that we're using so people can do it exactly the same way if they want to. So the option is there, if their budget allows, obviously. But at least they know the correct way of doing it, and then hopefully they won't alter it too much when they do it themselves, shall we say. They'll try and stick to it a little bit, but you never know.
Yeah. So on that subject, like on the subject of the cost, if you go to the contact form on your website, the first thing it says, all the conversions are about £25,000 or more, or I can't remember the exact wording. Why do you think these things are so expensive? And do you get loads of people actually asking? Well, presumably you get loads of people asking you, like, can I do it for 10 grand or $5,000?
Yeah, this is the main reason we've got that on there, is because I was bored of getting hundreds of emails of people that were never going to do it. They just randomly liked the idea and thought they'd ask the question. But actually, they could never. So I didn't, because of how busy we are, I basically didn't have the time to be replying to all these people asking these little random questions. So by doing that, it's just sort of removed that, and I can actually do the customer service correctly to the people that are serious. I mean, for instance, the kit we're using, the Hyper 9 kit with the LG pack that we're using and stuff, I mean, that's still, I think that's about 18 grand in parts, all the bits.
Wow.
It's still quite a lot of money. But that's why we say 25, because by the time you built that into a battery pack and you built all the brackets, done all the wiring, you're at 25 grand quite quickly.
Yeah. Once
you've actually built it into a full bolt-in system. I mean, like our Porsche kits, for instance, I think are 48,000 plus that, a Porsche kit.
Wow.
I mean, that's all brand new components, and we've been working on it now for 8 months. So there's a lot of man hours, a lot of development time gone into it to make everything bolt in. But that's, when you break down what you get, you get all your braking systems, your power steering, your HVAC system. So it's every single item, not just, you don't just get a motor and a battery. It's everything is fully bolted in. 40 hours you convert it to Porsche sort of thing. That's sort of the way that's been set up. And it depends on the vehicle as well. So like a Porsche, an engine rebuild on a Porsche 964 is about 35 grand for a decent engine rebuild. So when you take that into account and then go, well, I can spend a little bit more and not ever have to put petrol in it again, not have to get it rebuilt again, and I get more performance. It's sort of, when you weigh it up, I suppose it changes. There wants to be something more budget coming in for the cheaper vehicles like the MX-5s. It would be nice. Yeah. But currently, the batteries and the motors and stuff just don't allow for that.
I mean, it's still cheaper than buying a new Porsche, or even 2 years old Porsche. Because I can't remember how much you paid for yours, but it was like a couple of grand just to buy a Porsche with the engine that was off. £1,800 pounds, I think. Yeah, 1,800 quid. So if you top that up, if you add 50 grand on top of it, that's still pretty decent price for a classic or a Porsche with the electric drivetrain.
I mean that's like the high end. That's 500 brake horsepower. We're talking over 200 mile range, DC fast charging, complete custom gauges. That's like the highest quality conversion sort of thing, shall we say, with all the bells and whistles. Whereas obviously, like the MX-5 will be the lower quality, sort of not lower quality, but it won't have fast charging. It'll have 100 mile range, sort of that sort of stuff. So there's different tiers. Yeah. We are trying to get to the lower tier again, really, for things like minis and stuff, where you can have a lot, where you can maybe get down to the £15,000 for a bolting kit. That's what we want to get down to for some of the older classics. But what we tend to find now is that the OEMs that build the batteries are not helping because they're now building cell to pack. Rather than cell to module to pack, they're going from cell straight to pack. The issue is that means that actually, as much as people seem to think there's going to be loads of battery packs coming available to do DIY conversions, there's not, because you're not going to be able to use them. You're going to have to strip these packs apart. So this is the issue. So Tesla will go cell to pack. I think a lot of them will, and they'll move away from the modules because it's just another part within that, which is not necessary.
Yeah. I think, Model 3 battery packs are pretty much already just a single. I mean, there are modules in there, but they're all different. and the whole thing is just filled with resin, so it's
it's four modules, 2 modules the same, and 2 and 2. And then if you lift them out the pack, then there's no rigidity to them. They're really flexible because they're all plastic sided. So you've got to build them into another solid box that supports them. And on the Model S and like the LG batteries, they've actually got a removable BMS board that you can take off. Model 3 hasn't. It's soldered on the BMS board. So the only way of operating that battery then is actually hacking the software on the BMS board, which is people doing at the moment. So that's a sign of things to come. It's only going to get worse, basically.
Yeah. I mean, these cells are supposed to last, forever. So they obviously don't want people to take them apart. They want them to use it as a battery pack in a vehicle. Whereas the Model S is like a DIY heaven. You can just open it up and remove things and replace things, and it's the best thing ever.
Yeah, exactly. It's that mass production thing, I suppose. The Model S was a more expensive vehicle that took longer to build for them, whereas the Model 3 is how quickly can we build this, and how cheaply can we build it, and that's their approach. And all the manufacturers will go that route. VW, I think, will go that route quite quickly because they're going to want to be building at as tight a budget as possible to get the prices down. So yeah, as much as everyone thinks there's going to be loads of batteries appearing, they're just probably not going to be usable, or not easily usable anyway.
Okay.
Should be the issue.
Okay, interesting. We can talk about what's going on into converting a car to an EV, but I'm sure anyone, and like briefly, if I can summarize it, you basically obviously stripping down all the drivable components of the car. So you drive your engine, your transmission, and your fuel tank, obviously, but then you have to replace not just the engine with the motor. You have to fit the battery pack, but also there's loads of things in a regular ICE car that are actually driven off the engine, like air conditioning or power steering, that then you have to replace with the electric version, or something different. Is there anything I missed that goes into an EV conversion? I've obviously made it sound very easy, but
thing is, if you've got to look at it easily, because you just break everything down into components. I mean, yourself as electrical engineering, you might look at something and it's a huge task.
Yeah.
But as soon as you break it down into bits, it's not that bad. Which is why we're trying to do it broken down properly for people in sections. So today we're going to look at the motor setup, and next when we might look at just batteries, to do it into bite-sized pieces, basically. As you said, engine, gearbox, fuel system. Yes, you need to maintain power steering, brake vacuum, but that's all done on 12 volt. It's a 12 volt brake vacuum pump with a reservoir. It's a 12 volt power steering pump you get from the GM Vauxhalls. All those use them. Air conditioning, you can run a high voltage AC pump, or you can run a 12 volt AC pump. So all of that is now easily rectified, like with no big issues at all, really. And then heating, you need to replace the heater matrix with a PTC heater. So that's
okay.
Probably the bigger task, because you've actually got to pull the dashboard out and get to the heater matrix to replace it with a different one. But that's the fiddly, probably one of the most fiddly bits there. But yeah, I mean, in layman's terms, that's all it is. It's removing one lot of parts and then replacing it with the other one. It's the fabrication work that goes into it, and that fact that, I don't know, I get a message going, you could have freed up the gearbox panel and put batteries in there. It's like, no, I couldn't. Well, you've got all that space. But I've got space, but the space there isn't the same size space as the battery is. Unless you're going to build a complete custom battery from the cells up, that space normally isn't usable, because a battery module, say for a Tesla, is 30 centimeters wide, while the gearbox panel is only 25, so it doesn't actually fit. Yeah. So that's the sort of thing, is that, it looks like there's space there, but there's not. Well, we tend to find, that if we add another 2 centimeters, we could have fitted another 10 kilowatts. Or there's a lot of that tends to go into it, because they weren't designed for it to start with.
Yeah. And that's why, the EVs that are designed from ground up to be an EV, are probably the best, because they've done things, they've put things in the correct places. And quite often you're talking about the bits of the chassis that are load bearing bits that are calculated to be a certain way, so you can't just modify them and like expand them by 2 centimeters just to put something in, right?
Exactly. And you've also got to look at it from like crash potential. Yes, sometimes there is space in the back of the boot or right at the front of the car, but you don't want to go and put batteries there, because if you crash,
exactly.
you've got no crumple zone left.
Yeah. This is the thing that quite often people point about the very old cars, is that when they got into a crash or whatever, the car would be pretty much entirely sort of, so the car would be intact, right? But whereas now modern cars will kind of deform even if you crash into something at 30 miles an hour, but it's because they're designed to be that way, so that people are safer, basically. Whereas in olden days, you could probably die in a 30-mile-an-hour crash if your head was in the wrong place, because the whole car was just so rigid and stuffed with things back to back. Where do you get your battery cells from? You already mentioned, obviously, LG Chem. But did you?
So we have. I've got to be careful what I say. We have a contract with a company.
Okay.
And we now take all of their X-Test, X-Demo, and overproduction batteries. Okay. Basically, from a certain manufacturer. So that's all I can sort of say, I suppose. Yeah, it's a pain, but we do also get batteries from breakers yards and stuff as well on top of that.
Okay.
But mainly the LG batteries we have over 1,000 of those modules coming in over the next 6 months.
Okay.
So we have a deal where we've taken the whole stock from a company, and we will continually take all of their batteries, basically.
Yeah, I think what the person was getting to is some companies, especially in the US, they sit on eBay or whatever, and they hunt down Tesla Model S battery packs and all that, and strip them down and then build the packs themselves. Or there's actually companies that repurpose those battery packs and repackage them essentially. But
that's what we do. Yeah, we do that a lot with Tesla batteries. Most of our builds we use Tesla batteries for. We just started swapping over to these LG batteries because the same thing in theory. The batteries we've got, they come from vehicles. We've just managed to get a proper deal with the company to take mass quantity of a certain type, which is going to be really good for the EV conversion market as well, because it's now going to be a good supply of those batteries. Yeah. Whereas everyone hunts for the Tesla batteries. Yes. Everyone wants them. So the storage people want them. Everyone wants to get their hands on them. So the price of them goes through the roof. Whereas the LG batteries we've got are, when you compare them against a Tesla battery, the kilowattage, for instance, say a Model S 5.2 kilowatt hour battery pack is normally around 1,200-ish quid. And then the LG battery packs, I think, come in at 1,000 roughly. So you're saving £200 per brick, basically, of what you would on the Tesla stuff. So we're trying to bring the prices down as much as we can, but it's still difficult, I suppose, because there's still a huge demand.
Yes.
And the demand, unfortunately, with what's going on at the moment with the virus, demand is going to now maintain for longer because all the production rates have slowed. So it's going to take probably another year now before that demand gets back to where it was before the virus. So it's now the demand on the batteries for conversions is going to be higher than it was before, because there's not going to be as much on the market.
Although I'm sure there's loads of people now stuck at home with a garage who are just, tinkering with their cars and thinking about converting it. Do you actually have a bit more inquiries about conversions now that people are stuck at homes?
I suppose we do a little bit. But I think that was one of the main reasons we started doing the MX-5, is because that filled that gap. That literally has come out since the virus has been here. So a lot more people are stuck at home. So the questions we get on that are a huge amount of questions on that, but that's all through just people commenting on it rather than people sending a load of emails. I think it's just got people thinking about it. So I expect, yes, there will probably be a lot more emails appearing. But obviously I do have that thing on our website saying a set limit, just to try and just to put people off that, because otherwise you just get overwhelmed with a huge amount of emails.
We spoke briefly about it, and you said the most people who convert these cars are converting usually classics, right? But is there any limits, or are there any ICE cars that you think it doesn't make any sense to convert, or could you convert anything, literally, your family car from your childhood that is a clunker and nobody would look at it, but you wanted to have it as an EV? Are there any restrictions, do you think, or is it just?
No, I don't think so. I think most people could convert most vehicles. Depends how much range they want. That's going to become a big sticking point because that's fitting batteries. The only thing we have found is, so in the UK, anything built after 2002 is classed as M1 classification. So it's extremely difficult or nigh on impossible to change the tax band. So it means even if you convert it to EV, the chances are you will still be paying the standard road tax you were paying before you converted it, because they basically put a lockdown on it.
Okay.
Now, obviously, it doesn't really affect that many people if they've still got to pay a bit of road tax. They're not paying for that. They're not filling out with petrol and they're not doing the other stuff. That's the only sticking point we found, and that's why a lot of people don't touch the newer stuff. It's because there is that hassle, and the newer stuff's a pain with all the CAN bus and the inbuilt electronics to keep everything happy. You also, with the new stuff, with all the airbags and stuff, you've got to be very, very wary of, if I'm going to put a component in a set location and someone has a crash, is that then going to impair and affect safety systems on the vehicle? Because it's actually now got a battery pack where it never used to have one, or this is one of the things. So, like the Porsches, for instance, we have a battery pack in the rear where the engine was, and we have a battery pack in the front where the fuel tank was. We have not, and we don't put batteries where wasn't already originally a mass of either a fuel tank or an engine or a gearbox. We try and avoid any other areas. So because you just don't know how the safety systems are going to cope if you suddenly put something further forward than it originally was. The crash zones. So there's that high risk that people don't quite. When I turn around and say there's a huge amount of development that's got to go into a newer vehicle, people don't understand that side of things. Yeah, but if someone has a crash in that vehicle and it affects that safety system, it comes back on us quite massively, obviously.
Yeah.
We could have caused something, and we don't want to be involved with causing anything like that. So there's certain vehicles we will avoid, and there's limitations to the size of packs we will fit. Some people will go, "Oh, you could have put another 20 kilowatts of battery in the front." It's like, yeah, but there was never anything in the front in the first place.
Yeah.
So putting potentially dangerous batteries in the front of the vehicle in the crash zone is really not recommended.
Yeah, and it's also about the sort of the weight distribution, right? So it handles properly and doesn't go sideways when you're cornering or whatever.
No, I don't know. That's the fun bit.
So the last question from my listeners actually. Is there any chance you could do, or have you looked into like extending the range of existing EVs? It kind of goes into your previous answer, I suppose, but there's
people that have done it to things like Nissan Leafs and stuff. It's not something we've ever looked into. I don't know if we ever will look into it. The issue we find with them is that the OEMs continually do updates. So as much as you might bring a range extender out, say for a 2014 Nissan Leaf, you might find as soon as it goes 2015, 2016, they've made a change to the CAN bus messaging, and then you've got to redo all that work again. Yeah. I think it is possible to do the range extenders, and I have seen it done. It's just how you do it safely, because these cars were never designed to have a second battery pack. So how do you maintain it? Where do you mount it to? How do you tap into the high voltage system to add that in? So there's quite a lot of things that, how do you do that in a safe manner without jeopardizing the car? Because a lot of these cars are still under warranty as well. So it's like, how do you make it reversible? Doesn't affect warranty. There's just so many. And you tend to find that, so for the Nissan Leaf, for instance, someone that has an older Nissan Leaf and says, "You know what, I'll put range extender in," I will tell them no, because why not just go and buy a battery pack from a newer Nissan Leaf and put it into your older Nissan Leaf, and then have someone upgrade the software, because Nissan didn't change the form factor of the battery pack externally; they just changed the internals. So you tend to find that a lot of the older Nissan Leafs, the battery pack is visually identical all the way through up to some of the newer stuff, and all they've done is they've just improved the battery, the chemistry inside. Yeah. So they are interchangeable. There's only certain companies that have the software and stuff to do it, but that's an option I think that people should look at before they go into looking at adding a range extender into the boot. Actually look at, can you just do an upgrade of the original pack? Take one pack out, put a new pack in.
Yeah, because we have a Nissan Leaf, and I'm on quite a few forums, and there's loads of companies from Eastern Europe usually coming up on those forums and advertising that they they're happy to replace the battery pack. I don't know how would you drive the car there and back, but that's a different matter. Maybe they're hoping that there's somebody from local area who would be interested. But I
think people do it with the i3 as well. So BMW i3 did the same thing, different battery pack, but visually the same. So it's just a software update and swap the pack over. Some of the OEMs actually offered it. I think BMW actually offered a battery pack upgrade for a short period of time before suddenly removing it. But yeah, so I think that will be the process that I think people will go through or work on, rather than sticking another battery in the boot or something and then trying to find a way of connecting it into the high voltage system.
Yeah.
Because you also got to be really careful that the battery pack you use has the same chemistry, so it has the same discharge rate and all that stuff. Because if you go and stick a pack in that's a lot newer and can discharge power a lot quicker, then you end up with big issues on one pack depleting quicker than the other. You also get temperature issues. And you've also got to make sure when you connect those packs in, because you're going to be putting them in parallel, they have to be at the same voltage when you connect up.
Yeah.
You can't just go and stick the other pack in whenever you want, even if one's nearly empty, and put one in the full, because the packs will try and self-balance between each other and overload, and potentially you could have a huge fire risk. So there's some big concerns there. So people have got to be very careful.
Yeah.
So I would always say try and upgrade the pack within the physical car, rather than putting a secondary pack in if you can help it.
Yeah, it's kind of like when you buy a trinket for your house or whatever, and it's got AA batteries. It always says in the instructions, do not mix the batteries from different manufacturers. It's the same thing but on a much bigger scale, basically.
Yeah. Because if you take two batteries, one at charged up to 20 volts and one charged up to 25 volts, and you connect them in parallel, they're gonna try and balance themselves pretty quickly. So it's and that's the risk, is that balancing rate, unless you put a system in place between them to manage that balancing, to slowly discharge across the batteries, then fine. And that's how people do it anyway. So say we got a battery that's one's lower or higher than the other, we'll charge one up or we'll discharge one to balance them before you put them in parallel. So that's something you have to do. You have to make sure your overall pack is exactly the same voltage before you connect them up, if you do something like that. But as I said, right now, it's not something we'd recommend. We'd recommend actually upgrading the pack itself rather than putting a secondary pack in.
Yeah, and I think famously Robert Llewellyn recently has said that his original Japanese build, Nissan Leaf, will get a 40 kilowatt hour pack now, because you can just slot it in. I think the only difference is that with the 62 kilowatt hour, there's a slight difference in the way the size of it, but I don't know enough details to say whether I know they've changed the pack internally. Whether that changes anything on the outside or not, I don't know. Hopefully not, because obviously, from manufacturing perspective, it's easier for them just to make it a replaceable component, right?
Yeah. And that's what you'll find with a lot of the OEMs other than Tesla, because Tesla don't seem to care about making rapid change. But you think VW, Nissan, any of those biggish companies, they will try and maintain the same pack design externally as long as they possibly can. Because, as you said, it's just one lot of development, one lot of machining, tooling. They will try and maintain that same floor pan and that same pack as long as they possibly can across as many molds as possible. And they'll just upgrade the internal batteries. So the hope is that they'll continue doing that. And then that will be the way that people can they have that choice then of, do I upgrade just my pack on my car, or do I buy a new car? But with EVs, with the efficiency and the potential mileage they can do in their lifetime, you think like a Tesla the Model 3 potentially could do 1 million miles.
Yeah.
So you're not, at that point, you're not going to want to be just changing your car. You'll change the pack. You'll put a bigger pack in when the new pack comes out. There's definitely going to be a huge market for that moving forward. Right now, maybe the demand's not quite high enough. As you said, there's going to be very limited companies, but I think in the future, in the next sort of 5 to 10 years, you might find a proper group of companies that all they do is battery upgrades to older vehicles for people.
Yeah.
So it's got that cost. That cost has got to come down, and the OEMs have got to actually start selling those packs to those companies as well. But a lot of the OEMs won't, because they want people buying new cars. That's going to be the sticking point, I suppose.
Okay. I suppose on Nissan Leaf, it becomes an issue, as I know from my own experiences, because the battery pack is not cooled or there's no temperature management on the battery pack at all. So they obviously degrade slightly quicker than, say, Tesla would do. So, my battery pack is like 89% or 88% state of health after 50,000 miles. And if it was in a Tesla, or if it was water-cooled, it would have probably been, well, I know it would be better off because I've got sometimes very heavy right foot, so it's,
the big issue with the Nissans was the charging. That's what it was.
Yes,
it was the CHAdeMO charging. It fitted CHAdeMO charging to a non-temperature controlled battery pack. So that was what destroyed it. The discharge rates, as long as you're over, say, 10 degrees and stuff, you're not going to do huge amounts of damage. It is that charging at low temperatures at 50 kilowatts or whatever it was they set it at. So if you find a Nissan Leaf that didn't have CHAdeMO fitted, so with the little 3.3 kilowatt charger or whatever it was, the chance of that battery pack in that car will be in way better health than any others you'll find.
Okay.
Just because it hasn't had that fast charging.
Okay. Yeah, interesting, because I've heard people saying that it's kind of, it's finding the right balance. So lots of people use CHAdeMO to kind of fix the state of health. So if you discharge and charge rapidly the battery pack a few times on the trip,
right,
that kind of balances the pack better and it comes back. But were they selling the cars without CHAdeMO in the UK at all? I thought it was a US thing.
There was a couple I've seen, but not many. Very. Or someone that has CHAdeMO but never uses it is the other thing.
Yeah.
There's some people that actually, they have the little Leaf as a little pot around town car, and they would never actually need to do CHAdeMO charging. They just park it up and do it at the house with the little charger. So, yeah, I suppose it's difficult, shall we say?
Yeah. So on the subject of rapid charging, and do you fit fast charging or rapid charging plugs in the cars that you convert, and how do you do that for most of the cars, or is it kind of user's choice basically?
It's user's choice. So the battery management system we use allows for CHAdeMO charging, CHAdeMO, so we can do that, no problem at all. The real sticking point charging wise recently has been CCS.
Yeah.
The software stack for the CCS stuff is ridiculous. It's so overcomplicated. It's a right pain, and there's so many companies just struggling to try and get something to work CCS wise. We have just started working on CCS ourselves because we've got bored of waiting for someone to come up with a CCS solution. But it's a lot of work to do it. So hopefully we might have something soon in the next, say 6 months, maybe a bit longer, but that'll be nice once TCS comes along. But yeah, I mean, it's down to customers' choice. Most customers aren't too worried. Sometimes we'll do a 6.6 kilowatt charger, or maybe we'll do 11 kilowatts or 22 kilowatt AC chargers instead, if the space allows for it, rather than fitting the fast charging. But that it's all down to customers' preference. A lot of people don't even need it and don't even think about it. If they've got a 200-mile range, most of them are like, well, I don't need fast charging, especially in a classic, because they're never going to do that many miles.
Yes.
If someone goes 200 miles in an old classic, doesn't want to stop, then, I'm quite surprised, to be honest.
Yeah, probably the original engine would probably break down every 200 miles anyway, so they used to not driving that far for safety, basically. Right? Exactly.
I mean, one thing that's in the back of my mind all the time is, when will the manufacturers stop fitting AC charge options to cars? This is when I'm waiting along. I do think as the DC fast charging technology advances, I do wonder whether they will remove the AC fast charging from vehicles and expect people to have DC chargers at home instead. Because the DC chargers are getting a lot smaller. So we've just bought a 10 kilowatt DC charger, which does CHAdeMO and CCS for us to use for testing in the workshop. So that's 10 kilowatts. It's a little small box. So it means we don't, so for like my Skyline, for instance, that we use for race stuff, well, we don't want the weight of a charger in the vehicle at all. If we can do away with the onboard chargers and just have DC only and have a portable DC charger to charge it with, we'll do that instead.
Yeah, that's
so I don't know whether there will become a time when actually that happens, and that won't be in the vehicle. It will actually be a little transformer on the wall in the house, and all the Type 2 stuff will go, and maybe it will just become a DC unit instead. as it gets more and more compact and more advanced, you might find that happens.
Yeah.
But I don't know. And if people start doing rapid charging, like a petrol station setup, basically, you'll tend to find that actually people don't use their AC chargers as much, and they'll just stop. They'll pull over and fill up stupidly quick at a petrol station or something. So there may become a point where it may be an optional extra to have an AC charge point on your car at some point. I mean, that's probably 10 years down the line or more. But that will probably happen as battery technology gets more advanced and you charge faster and faster and faster. I think it will get to a point where people won't be plugging in at home long term. They'll just pull up, plug in for 5-10 minutes, do a full charge, then go on their way again. So you may find that the AC bit becomes an optional extra in the future, but that's going to be quite a long time away.
Yeah, well, that's an interesting point, because I think the petrol stations as we know them are going to be a thing of the past. So that you're going to have, that's why loads of rapid chargers are actually fitted at like pubs and restaurants, because that's where people go, right? And that's why they want to stop on their journey. Nobody will stop at the at your, we can't feel. People will just be charging at home. But it's a good point about the DC, because I know this might sound a bit stupid, but people should know that you can charge your car on a DC charger or a rapid charger slow. So you could in theory tell CHAdeMO or CCS charger just give me 5 amps or whatever. It's just the voltage has to be matching. It's very diverse. So you've got a real diversity of ranges and speeds you can charge at. So that's one of the benefits with it, is you're not limited. You can charge at say 120 kilowatts if you need to, or right down, you said like 5 kilowatts or lower. So you're not, as you said, you can really vary it. So that's the only thing, is it becomes a connector which has huge diversity, and you're not limited by your onboard charger. Yeah. So it's, I don't know. I think long term maybe something that happen along those lines. But we'll see. It's interesting. It's interesting to hear different people's opinions, because I know about people who have DC charging at home, but it's because they have the vehicle to grid box on their walls. And obviously that's different. And it's
if you think more and more houses will have batteries at their house. And that is what's the point in converting that to AC to convert it back to DC? Okay. There is no point. It's efficiency. You lose a huge amount of efficiency converting it all to AC to then convert it back to DC again. It's pointless. So I think you will find that people will have their battery packs at their house with their solar, and then they'll have a DC charger instead. Because there's already a DC. There's already AC to DC converter built into those battery packs usually. So if it's integrated with a car charging, it's interesting. I'm like I say, CCS protocol is so complicated. I'm actually surprised that European Union has went with it, because the I don't understand them why go with it. CHAdeMO works. It doesn't quite. CCS guys go faster charging speed, admittedly, but it's just so complicated. I haven't really got anything good thing to say about it at the moment. They're nice because it's the Type 2 and it's got the but. Apart from that, it's very, very frustrating from a company point of view, and from someone that wants to offer CCS, it's an absolute nightmare. I mean, but then maybe they've done it for a reason, because they don't want EV companies, they don't want DIYers playing with DC charging. Then there may be reasons behind it, but it is quite frustrating. I think it's because it's going to be the most common charger in Europe. I think it's mainly political reasons, like because CHAdeMO is controlled by Japanese consortium, whereas the CCS, is like I don't think they have CCS as much in the US or in America as they do around here. I don't know. It would be nice if there was just one single charger, charging format, but we can all dream. We can all dream.
I mean, the other advantage of actually having DC fast charging like CHAdeMO at home is the and this kind of ties into my I had a conversation previously with Jordan Brompton from Zappi. I don't know if you know Jordan, but Their frustration is that they can't talk to the car over the AC charging, because you just have the Pilot, which is just
resistor based.
Yeah. Which is, so you can't exchange any information with the car, or not as much as you would, because I think the car tells you how much power it needs, but it's a pulse width modulation sort of quote unquote protocol. Whereas if CHAdeMO and CCS, you have a serial port essentially, right? So you send messages.
So you can do, in theory, you can do payment basically is the way it's going to be set up. So your car will say hold your PayPal details or whatever you choose to have, and when you plug in, payment will be done there at that point. That's the hope long term. I think is it Tier 5 or something? There's a new thing coming out basically, which is based on plug-in payments. So it will be done at that point. You don't have to flash a card in front of the machine or anything like that. You literally plug your car in, and it will do all of that part for you.
I think
the way it's going.
Yeah, I think Audi and Merc are already doing it on the Ionity. Whether it's their own thing or whether it's the next version of the CCS protocol. But it's the next version. I think it's definitely the next version. Because Tonic Energy, who we work with, who they've one of our sponsors, they've been looking at and working on that sort of side of things. There's definitely it's a new part coming out and being pushed onto people. But it just means that you haven't got to have all these different apps, all these different cards, all these different things for all these different chargers. Subscriptions.
Everything's got the same thing. It's just you plug it in and that's it. It's done. There's none of this. You said subscriptions and it's a headache.
Yeah, it is. Yeah, I remember before getting my car, I had to subscribe to all these things, and I was thinking to myself, why? And back in the day, you had like Midlands, and like every region of the UK had its own charging network. Like we had our own in Kent. There was one in London. It's just like, why do I need all these cards? I still have loads of cards.
Why can't they just accept contactless payment or Apple Pay? Why have they all got? It's just it's very frustrating. It wasn't. I don't think it was thought about particularly well. But luckily, there is this new process procedure thing coming in, which should mean that you can be plug in and take payment rather than have to have all these subscriptions and stuff, which I think will be very, very good when that happens. And it'll make everyone's life a bit easier. A bit like Tesla do at the end of the day. You drive up to your Tesla supercharger and you plug your car in.
Yes.
Tesla have been doing it since, 2013, maybe before that. So, why... why is someone else doing this? They've been doing it for probably 10 years now.
It's a separate discussion, but I'm pretty sure I've already I've alluded to this in previous episodes, but I think it's just commercial and political reasons. Like all these networks have to have subscriber base to actually have some sort of a net worth to be either financed or loads of them still to this day sell the data, and that's how they fund part of the development. So it's none of it is in service of the customer at the end of the day, which is the difference from the Tesla approach, where they want to serve the customer. That's at the end of the day, that's the way you should do business, right? You shouldn't try to make money otherwise, like selling the customer data. You should just benefit from the customer's custom, right? I don't know. Yeah,
well, it's easy to see how well they've done. It shows that that's the approach that these charger companies should take. But
precisely. Anyway, and anything else you want to add? Like any what's the future holding for ZeroEV? Like what's the?
We've got loads more things on the development that'll be coming out in the next 6 months. We are working with a fair few companies now that we supply to anyway in the industry, which they'll be bringing out purpose-built vehicles that are electric, which should be really interesting. But we're going to, I think, mainly focus on developing some cool new products for people, and our kits. That's going to be our main thing, is the full, complete, developed bolt-in systems, which is Porsche 911s is what we're doing at the moment. We're also doing Mercedes Pagoda, Jaguar E-Type. There's a couple of other vehicles we're looking at, but we're going to start with them, and then we're going to develop on from that, really, and start opening the market up. But it does also mean that we should be able to start, because we'll be going into volume, like 10s, 20s or more of a set kit in a batch. It's going to hopefully allow us to start looking at bringing the cost down on kits, because we're going to be batch producing them, not producing them as one-offs.
Yeah.
So that's the plan. We may look at minis. We don't know yet, but there's a couple of companies doing them. But we really think that we can do a lot cheaper kit. Everyone's been looking at super high performance, basically. And we did. That's where we started. But we're now looking at going, well, why not just stick to the original performance of that vehicle, but make the kit affordable rather than going crazy high performance and make it out of reach for a lot of people. So yeah, we think we may do some more mass production stuff. Some hope for some of these other sort of more round town cars long term, but right now we're focused on the high end Porsche stuff and things like that currently.
Yeah, okay.
We'll see. Everything changes so fast these days.
True. Especially under the lockdown, it's...
Yeah, exactly. It's given us time to catch up. Yeah, we've got CCS stuff we're working on. We've got some of our cool new circular displays and stuff that we've been working on for a while, but they're finally finishing up on their development now, so they'll become available soon. Arrange a little bit like that. I think should help a lot of people fill some gaps in the market, hopefully. Cool.
Like I said, I always have loads of questions that I don't want to bore you, and I don't want to take up too much of your time already. And I always like to leave things for another day if we want to have another conversation at some point. So, anyway,
cool.
Thanks very much for appearing on Take It EV.
No problem. All right. And thanks for having me. It's been interesting.
Well, that's it for the episode 17. Thank you for sticking up with me. Let me know what you think about it. Follow us on Twitter at TakeItEV. Let us know what you thought. Follow Chris and his company at ZeroEV on YouTube. He's got an amazing series converting MX5 to electric at the moment. And really good tech talks where he explains all the sort of nitty and gritty of the EV conversion, how electric cars actually work. Also, have a look at the Patreon link. Just look for Take It EV at patreon.com. It would really help us if you chip in a few dollars or a few quid every month. And thank you very much. Bye.